So thermodynamics tells us whether something is favorable in terms of energy. Heat and entropy combined into free energy. We use the phrases thermodynamically favorable, meaning that it releases free energy, or thermodynamically unfavorable, meaning that it requires it or it won't happen on its own. We used to use the word spontaneous. Spontaneous means the same thing as thermodynamically favorable. It happens without the input of outside energy. The problem was that that spontaneous word is used in so many different ways in our language that a lot of times people think that it means it happens fast. But really, thermodynamic favorability and speed are two different topics. And we'll see that. Kinetics is an important topic. We've covered that already. That means, are we going fast or are we going slow? Fast or kinetically favorable or kinetic control just means that whatever the process is doesn't take very much time. We turn to reactants to products very quickly. But that could be because we're putting in energy to make it happen quickly, or it happens quickly on its own while releasing free energy. A really common example of something that isn't necessarily kinetically favorable to start, but is thermodynamically favorable to start, is a combustion. Meaning, when we burn something, we release a bunch of heat. We often increase the entropy a lot, and we have a very negative delta G. But those reactions don't happen on their own. They don't just start. It's very rare that we have something spontaneously combust. And when we say spontaneously combust, that means happens on its own or happens kind of quickly. To burn or combust things, we have to put in energy. We spark it, we light it. When we're thinking about a piece of paper, a candle, or any of those things, we put in some energy. That energy that we're putting in is the activation energy. And we've got some ideas here, or some graphs here, excuse me. When I have a really high hill, that means I have to put a lot of energy in order for this to occur. When I have a lower hill, that's a lower activation energy, and it will occur more quickly. How high or low we are in terms of delta G, how positive or how negative our delta G is, tells us how thermodynamically favorable it is. But how big our activation energy tells us how much energy is needed to start this. So it's totally possible to have a negative delta G, a very favorable reaction from a thermodynamic sense that won't start or won't happen very much on its own to begin. So that rate doesn't mean that it's not favorable. It just means that it's a kinetically controlled process. One example here is diamond turning into graphite. Because of the entropy changes here and the strengths of those bonds, it is actually a negative delta G. Not very much. It's like negative a few kilojoules per mole. But it does increase the entropy. It does have very similar bonds. And depending on our temperature, even at room temperature, it is favorable. But the activation energy is so high because to get these bonds to break apart into that, we have to put in a whole bunch of energy for it to start. So delta G by itself just means that it's thermodynamically favorable, or at certain conditions, it can proceed without outside energy. It doesn't mean that it's going to happen fast, and it doesn't mean that it's going to start automatically or quickly.